these are the notes for how to do area and perimeter with composite figures. So first off, it says what a composite figure is, and it's a figure made up of one or more basic shapes. So for the first page, we're going to just area. It says find the area of the composite figure, use 3.14 for pi. So we look at the figure and we see what shapes that this is broken into. I see a rectangle. And then I see two identical semicircles. And I know that the two semicircles would form one circle. So I'm going to say a circle. Okay, so now here's how I want you to make sure you're setting up your problems. So I'm going to start by writing down my first shape. So I have a rectangle. I'm going to write down the formula, which is length times width. I'm going to substitute in my numbers. So I look at the length of my rectangle. I see 16. I see the width of my rectangle, and I see 4. And 16 times 4 is going to give me 64. So I know the area of that rectangle portion is 64. And then for my circle, then I'm over here, I'm going to write circle. I'm going to write my formula. Area of a circle formula is pi r squared. I'm going to substitute in what I know, 3.14 times the radius. Now, I know the diameter is 4, which means my radius is 2 squared. I'm going to put that in my calculator, and I find out the area of my circle is 12 and 56 hundredths. And again, I did a full circle because I know two semicircles come together to form one circle. And then I'm going to show my final step over here. If I add my two together, so 64 plus 12 and 56 hundredths, making sure I line up the decimal point, though I can use a calculator too. But if I'm going to just do it myself, I get the final answer of 76 and 56 hundredths. And now I'm going to label it because now it's my final answer. And it's area, so I always do units squared. So 76 and 56 hundredths meters squared. Let's try this again. We have two shapes here. The easy one to see is probably right here, and that's a semicircle. And then this shape right here, I'm going to turn it this way. You might be able to see it a little bit better. This is actually a trapezoid. So remember, a trapezoid is a figure with 4 sides, a type of quadrilateral, and the only thing a trapezoid has to have is a pair of parallel sides. So this side right here and this side right here, those are parallel sides. They will never, ever, ever touch. They'll just go on forever. So I'll do my trapezoid first. And there's several different ways that you could write the trapezoid formula. So you can use whatever one works for you. I was always taught 1/2 times height times base 1 plus base 2. So that's what you'll see me use a lot. You could say height times base 1 times plus base 2, all of it divided by 2. That's another way of writing it. But the important part is filling in our information in the right way. So I'm going to say 1/2 times the height. Okay, to determine the height of your trapezoid, you have to find your two parallel sides, which are right here. And the distance between your two parallel sides, that's your height. So in this case, it's 3 times. And then to determine your bases are always those parallel sides. The set of parallel sides are always your bases in your trapezoid. So in this case, I would say 6 plus 10 or 10 plus 6. It doesn't matter. Now, when I go to put this in my calculator, be careful. You can use the parentheses if you want. You could do this in your head. But if you just write 1/2 times 3 times 6 plus 10 in your calculator, it's going to do order of operations, and it won't do this first. And that's what you need it to do first. So if it were me, I would say 6 plus 10 is 16. And then I'd say 16 times 3 times 1/2 in my calculator. And I find out that the area is 24. Now I'm going to do my semicircle. Okay, so the area formula for a semicircle is pi r squared, but because it's a semicircle, I'm going to say divided by 2. So I have 3.14 times my radius. right? I know my diameter all the way across is 3. So my radius is half of that. So 1.5 squared divided by 2. And all of this you can put in your calculator just fine. When you do, you would get that the area is 3.5325. So then your final step is just to add them together. So I have 24 plus 3.5325. And notice I lined up my decimal points. I could even add up or add these zeros in. And I find out that the area is 27 and 5,325 ten-thousandths. And since this is my final answer, I'm going to label it centimeters squared. All right, area of this shape. So I see a square, and then I see 4 semicircles. Or you could say I have 2 full circles, because if I put these 2 semicircles together, I'm going to get a full circle. And if I put these 2 semicircles together, I'm going to get a full circle. I'm going to start with a square first. So you could say area equals length times width, or a fancy one for squared is side squared. I know the length of one of my sides, and since in a square all sides are the same, I would say 10 squared. I know my area is 100. Okay, I'm going to do a full circle. And then behind it, I'm going to write times 2 to remind myself that I have 2 full circles here. You could have also chose to do a semicircle, and then at the end I would write times 4 because there's 4 semicircles. Either one would be acceptable. So I know the area formula for a full circle is pi r squared. I'm going to fill in what I know, 3.14 times my radius. I've been given the diameter of 10, so my radius is 5 squared. And when I find the area of one circle, I get 78.5. But that's one circle, and I have 2 of them. So I'm going to say times 2 to get all of these covered, this circle and this circle. And when I do that, I get 157. So then again, my final step is to add them together. So I have 157 plus 100. I know my final answer is 257 millimeters squared. This last one's a little bit different. It says find the area of the shaded figure. And then it tells us 5 feet is the diameter of the circle. Okay, so I just want the shaded portion. So what I need to do here is I need to find the area of the shaded, and then I need to take out the area of the white triangle. So I see a circle that's shaded, so I'm going to start with my circle. And I know that formula is pi r squared. I'm going to say 3.14 times my radius. Well, if my diameter is 5, my radius is 2.5 squared. And then I find out that the area of my circle is 19 and 625 thousandths, 19.625. Okay, the next shape that I see is a triangle. And the area formula for a triangle is base times height divided by 2. Now, to find the base and the height of a triangle, you always look for a 90-degree angle. So here's a 90-degree angle, and the 2 lines that make up that 90-degree angle, so I have this line right here and this line right here, that would represent the base and the height. And it doesn't matter which one you put in which place. So this line down here had a value of 3 times this height right here had a value of 4 divided by 2. And don't get overly reliant on your calculator. This is easy for you to do. 3 times 4 is 12, and 12 divided by 2 is 6. So I know the area of that triangle is 6. So if I want the area of just the shaded region, here's the area of the circle if it was all the way filled in. But now I want to remove this white unshaded triangle. So since I'm removing something, instead of adding, this time I'm going to subtract. Make sure my decimal points are lined up. When I do that, I get a final answer of 13 and 625 thousandths. Now, since it's my final answer, I'm going to label it feet squared. So these are all the area problems. On the back, we have 4 perimeter problems, distance around the figure. And again, we're using 3.14 for pi. So you're going to notice the first 3 shapes are actually the exact same shapes we used on the front. We just also put them on the back, and now we're going to find the perimeter of them. So keeping in mind that perimeter is distance around the shape, I always like to use my finger and go around the shape, and as I go, I write down the length of the side, or you could use a highlighter or a marker or a pen. Okay, so as I go around the side of the shape, I'm going to say, okay, this is 16, so I'm going to write it down. And now I need to find this curved part right here. But I don't know what that is. But I do know that's a semicircle. So I could say, and remember, now we're finding the distance around, so I want to know the value of this arc. You did that yesterday in your Khan assignment. So the value of an arc, that's the circumference formula, so pi times diameter. But because it's a semicircle, I'm going to say divided by 2. So 3.14 times the diameter from here to here, I know is 4 divided by 2. Okay, so when I do that, I get 6 and 28 hundredths. So I'm going to write that down. So I'm going to add that to it, 6 and 28 hundredths. So now I've got around here. Right, now I need to know this right here, but I know that these are congruent. So I know if this is 16 down here, then this is also 16. And then I need to know this piece right here to get myself all the way around. And these are congruent. This arc right here and this arc right here are the same value. So again, I'm going to write 16 and 28 hundredths. So if I add them all together, it's going to give me my answer. My final answer then should be 44 and 56 hundredths. We're talking about a distance, so now my units are just meters. And this is one way you could have done it. You could have said, oh, I have 2 lengths of 16 and said 16 times 2 is 32. You could have said, oh, I don't have a semicircle, I have a full circle, because if I take these 2 and push them together, it's going to make a full circle. So you could have just done pi times diameter and come up with a full circle and then added those 2 numbers together. So there's different ways you can solve all these problems. All right, this one. There's a missing piece that you need to know. So the length of this right here is 5 centimeters. So let's find the distance around. So I'm going to start with the easy stuff, what I know. So I have a side that's worth 6. I have another side that's worth 5. I have another side that is worth 10. 0 there. And then I need to figure out this piece down here. That's going to be the tricky part for us. So we have to find the distance of this arc, just the arc piece, not around the semicircle, just the arc. So when I do that, I take my circumference formula and I'm going to divide it by 2. And that'll give me the distance of my semicircle. So I have 3.14 times my diameter, which has been given to me 3, divided by 2. And when I do that, I get 4.71. So I know that's the last piece I have to add in. So if I add all of these together, I'm going to get an answer of 25 and 71 hundredths. That's my final answer, so I'm going to label it centimeters. Okay. Here's this shape. In this case, the square is not even going to matter because not any of the sides of the square are part of the edges of my shape. My shape is simply made up of 4 semicircles. Or I could, like I did before, say it's made up of 2 circles. So there's 2 ways you could do this. You could find the area of a semicircle and multiply it by 4. Or you could find the area, or not the area, I'm sorry. You could find the circumference of a semicircle and multiply it by 4, or the distance of the arc, of a semicircle and multiply it by 4. Or you could find the circumference of an entire circle and multiply it by 2. Either way will work. And that's how I'm going to choose to do it. So I'm going to say pi times diameter. So 3.14 times the diameter of the circle is 10. So that's going to give me 31.4. And that's if I had 1 circle, but I actually have 2 full circles here. So I'm going to say times 2. And I find out my answer is 62 8/10 millimeters. All right, my last one. So I have, it looks like a rectangle that has a semicircle taken out of it. So I'm going to write down my sides as I go. So I have this side that's worth 22. And I have the top side that is also worth 22. I know that because opposite sides are congruent in a rectangle. I have this side that's worth 5. Now I need to find this semicircular arc. So that's where my formula is going to become involved. I'm going to say, to find that arc, I need to take pi times diameter, and I need to divide it by 2 since it's a semicircle. So I have 3.14 times, what's my diameter? Well, if this side is worth 5, then that side would have to be 5. So my diameter would be 5 divided by 2. If I put all of that in, I'm going to get 7 8/8500. So I know that this piece right here is 7 8/8500. So that's the last piece I have to add to my other numbers. And in the end, I find out the total of this is 56 8/8500 millimeters. And that's how I find the distance around a composite figure and the area of a composite figure. If you have any further questions, make sure to ask the next time you see me.